Hello, algebra students. Welcome back. Thanks for tuning in today. Flipgrid question is up there. Go answer it. It's good fun. You've already found the YouTube lesson if you're here. Now, pause the video, try this problem in your notes, and then unpause it to do it with moi. Okay, we are asked to factor the polynomial d squared minus 10d plus 25. First thing, so I could do it this way, but instead, the first thing I'm going to do is check and see if our pattern works. So, if I take a look at d squared, and I'm going to take a look at this 25, I notice that 25 is 5 squared. So is it possible that we could have plus 2 times d times 5? Oh, it is very possible. You see that? 2 times 5 is 10, and this makes 10d. Oh, minus, excuse me, minus, because that's a negative right there. So, okay, so what I'm noticing is that this is in the form a squared minus 2ab plus b squared, which means I have a minus b squared, so this must equal d minus 5 squared. There you go. Problem solved. If you did it this way and you said, oh, it's got to add to negative 10 and multiply to 25, you would have just gotten d minus 5. d minus 5. That works too. Totally works too. I don't mind which way you do it, as long as you're doing mathematically correct work. Alright, moving on to today. Our learning target and our success criteria for today. Learning target. You know how to factor by grouping. Grouping, we'll figure out what that is in a minute. And our success criteria is that you can factor polynomials completely. Completely and totally factored. Let's hop right into it. Vocab. What does it mean to factor something completely? This is what it means. To factor something completely means that you have a polynomial that is written as a product of unfactorable polynomials with integer coefficients. So, basically, you get at the end your end answer. I can't factor this anymore. I can't pull anything out. I can't split it up anymore. It is completely and totally factored. So, put that in your notes, please. And then, let's move on. Another thing that our learning target mentioned was factoring by grouping. What is factoring by grouping? Well, to factor by grouping, you need 4 terms. You could have more than 4 terms, but typically just 4 terms. And you group the terms into pairs. Factor the GCF out of each pair. And then you look for the common binomial factor. That probably makes no sense and has no meaning to you whatsoever. So, the best way to learn this, in my opinion, by an example. So, let's show you an example. Factor each polynomial by grouping. It just said, the last slide just said that we should take these 4 terms and we should split them up into pairs. Now, which ones you pair with which? You want to pair terms together that have something in common. So, for example, I noticed that these two both have a 2 in common, and these two both have an x squared in common. Now, these two both have an x in common, but then if I paired these two together, I would need to pair these two together, and they have nothing in common. So you want to make sure that you get 2 pairs that both have something in common. So let's pair them like this. And now what we're going to do is we're going to take this GCF, the greatest common factor, and we're going to pull it out. So, if I pull an x squared out of these two, I'm going to get x plus 3. Because I took the x squared away, and I took 2 of those x's away. Now I have plus, and I'm looking at these two now. If I pull this 2 out, I will get x plus 3. Oh my goodness, x plus 3. Would you look at that? Those are both x plus 3. This is where the magic happens. Because the x squared is being multiplied by x plus 3 and the 2 is being multiplied by x plus 3, we can rewrite it this way. X squared plus 2 times x plus. Now, can we factor this anymore? Is there any more factoring we could do? What about this? This has an x squared. Can I factor it more? No. No, I cannot. So this is my final answer. Awesome. Awesome, awesome. If that was confusing, let's do another example. This time, again, I need to pair terms up so that they have something in common. So if I look at these two, they don't have anything in common. That's an x and that's a y. They have nothing in common, so I can't pair those together. Ooh, but look at this. These have an x in common. That's good. And now if I look at these two, look at that. They have a y in common. This one also has an x, but both of them have a y. So that's good. Alright, so let me take these. I'm going to rewrite this. X squared plus x plus y plus xy. Sounds good. And now I'm going to take these common factors and I'm going to pull them out. So if I have x, that leaves me with x plus 1. Plus, I'm going to pull the y out, and that leaves me with 1 plus x. Aha! Now, x plus 1 and 1 plus x, that's the same thing. It's like saying 2 plus 3 versus 3 plus 2. They're both 5. Doesn't matter which way you write it. So, now I can write this as x plus y times 1. And I cannot factor that anymore. Awesome. Awesome, awesome. There is our first example about factoring by grouping. Done. Totally done. Let's make sure that we were right. X plus 3, x squared plus 2. And x plus 1, x plus y. Beautiful. Beautiful, beautiful. Alright, the next thing I want to show you, this is like a summary of the whole chapter, of all of chapter 7. So here are the different ways that you can factor. Today we learned about factoring by grouping. On Friday last week, we learned about the greatest common monomial factor, just one term that we factor out. 7.3, we looked at those yesterday, and those were the special patterns. 2 squares or a perfect square trinomial. So it ends up looking like that. And then what we did on Monday and Tuesday was if you have any quadratic, you can break it up into 2 pieces like this. Any quadratic. Okay. Yes, so those are different ways you can factor. So if something tells you to factor, here are all the different ways. You might factor out a common monomial factor. You might factor by grouping. You could use any one of these to factor. So let's use all of those things we saw in the last slide. We'll pick and choose which ones we're going to use to factor completely. So let's color code for this. We're going to look at A first. We're going to look at 3x plus 6x squared minus 8. The first thing I notice is that there is a greatest common factor in all of these. Look, they all have an x in them. They all have an x. And let me leave that underlined. So let's pull the x out, and we get 3x squared plus 6x minus 18. Awesome. Next, I notice that I have a quadratic with a number in front of x squared. So I'm going to do the factors of 3 on this side and the factors of 18 on this side. So what we have 2 and 9, 2, 3 and 6, 6 and I guess we have 1 and 18 too, but 18's a really big number. I don't think that one's going to work. Alright, now let's check it out. 3 times 2 is 6. 1 times 9 is 9. Nope, those don't add to give me 6. Times 9 is 27. 1 2 is 2. Nope, those don't add up to 6. 3 times 3 is 9. 1 times 6 is 6. Nope, those don't add. 3 times 6 is times 6 is 18. Wow, that took me a minute. And that also does not add up. What is going on here? Oh my goodness. Silly, silly us. Silly, silly us. There is a 3 in here too. All of these have a 3, so we should have pulled out a 3x. Oh my goodness. If you saw that and you were like, Mrs. Dodge, stop, you're doing it wrong. Good for you. Good for you. X squared plus 2x minus 6. Wow, that makes things easier. That makes things easier. So now, let's take a look at, I know that I'm going to end up with 3x, x plus something, x minus something. I know that because the 6 is negative. So let's see, I need two things that add to 2 and multiply to negative 6. Multiply to negative. I don't know if there is. Factor of 6. We have 1 and 6. But that can't add to... That'll either get us 5 or 7. So that doesn't work. And then we just have 2 and 3, and that gives us 5 or 1, so that doesn't work either. So, just kidding. This is our final factored form, because we can't factor it any more than that. I won't do that to you on a test. On a test, I won't give you quadratics that you can't factor that. That's a little bit tricky. Alright, next. Move on to B. We have 7x to the 4th minus 28x squared. Hey, look at that. Now I'm noticing all of the things we can pull out, not just one of them. There is a 7x squared in common here. So if I pull that out, I'm left with x squared minus 4. And hey, x squared minus 4, that's, this is x squared minus 2 squared, which means that I have x plus 2, x minus 2. Because of that pattern, when we had a squared minus b squared, that's equal to a minus b, a plus b. Beautiful. So that our final answer. Awesome, awesome. Let's check and make sure that we were right. Yes, x squared plus 2x is unfactorable. So this is factored completely. And then, yup, difference of 2 squares pattern. Perfect. Perfect. We were right. One more example for you today, and then it is homework time. Now we want to solve this. Solve it. Which means in the end I need x equals something, probably or x equals this or x equals that. So first thing, I want this equal to 0. I want it equal to 0. So let's subtract 10x from both sides. And we'll get 2x plus 8x minus 10x. And hey, look at that. These all have a 2x in common. So let's pull that out. Five. Okay. Now, I can, because this is negative, I'm going to have x plus something and x minus something. Leave that blank. And now we'll come over here. We want it to add to 4 and multiply to -5. Well, the only factors of 5 are 1, 5. If we do 1 and -5, oh, that gives us -4. So maybe we need -1 and positive. Yeah, there we go. So we have -1, +5, so x plus 5, x minus 1. Beautiful. Oh, we forgot our equals 0. We can never forget our equals 0. Because if it starts as an equation, if you have this equal sign, you better have that equal sign at the end. You never just drop the equal sign. If you have an equation, it stays an equation. Alright. So now, remember, let's change colors. This means that 2x equals 0, or x plus 5 equals 0, or x minus 1 equals 0. Any of these things could be true. So if we divide both sides by 2, oh goodness, we are running out of space. If we divide both sides by 2, we get that x equals 0. If I subtract 5 from both sides, I get that x is equal to -5. And if I add 1 to both sides, I get that x is equal to 1. So here are our options. Let's write them so that we can see them a little bit better. X equals 0, x equals -5, or x equals 1. Any of those, or any of those will work. Okay, awesome. Fantastic. Let's make sure that we were right. 0, -5, and 1. Awesome, awesome. We're correct. Alright, that is all I have for you today. If you have questions, please be sure to tune into my live stream every weekday from 12 to 2 p.m. Email me, comment on this YouTube video, however you want to contact me to ask your questions. I'm happy to do so. Okay, and your homework, I know it looks like a lot, but remember, the more practice we get, the more comfortable we feel with things. So this is your factoring by grouping, this is factor completely, and this is solve by factoring completely. So, practice makes perfect, and remember that this isn't required, so you don't want to do all of it. Hey, just do one of each or something. Do what you want. Do what you want. Okay. And last, but certainly not least, your launch for today is from Amy Poehler. She's an actress. I very much enjoy her. And what she says is limit your always and your nevers. So, when we say always or never, those are very absolute statements. You never turn in your homework. Well, what if you have turned in 1 or 2 assignments? Then my statement isn't completely true. I could say it is very often that you do not turn it. Or if I were talking with Mr. Dodge maybe and I said, you never listen to me. Is that really true? Has he never listened to me ever in the entire time that we've known each other? No. So, staying away from these absolutes keeps us out of this mindset of you never do this or you always do this. You want to stay grounded in reality. Mr. Dodge listens to me. Should I say he always listens to me? Maybe there's 1 or 2 times he wasn't paying attention. But if I were to say he never listens to me, that's not true. And I don't want to be telling myself things that aren't true. So, if you say, if you say always or never, it's probably not true, and you want to stay in a mindset of things that are true. So if you say, they always laugh at me. No, they don't. You don't know that for sure. You don't know that. And you don't know if they're even laughing at you. And, I mean, you don't care anyways. Even if they are laughing at you, who cares? Who cares what they think? But limit your always and your nevers. Only use them. Never use. No, I'm just kidding. Only use them when it really is true. But keep that mindset of, oh, that might not be true. That, you know, always. No, maybe not. So, that is my launch for you. Take it with you as you go throughout your day. Have a wonderful rest of your day. Thank you for being here. Thank you for watching. And, yeah, bye.